Hello. Yes. Um, yes, we are looking at this question today. It says that consider the circuit below. So this is the circuit we are talking about. And the question says, calculate the magnitude of resistance X. This is our resistance X. And how do you go about it? It's unknown. Okay, this is the starting point. You see, when you look at the 9 volts, the PD across, is across what? This PD is across 5. So the PD across 5 ohm is 9 volts. And this PD is across both these resistors. So the PD across both 4 ohm and X is 9 volts. So what do we do here? This is what we do. We say VP, or potential difference parallel, is equal to V across 4 ohm plus V across X. Okay? But V parallel is known, is 9. Okay? What is this one? You have to remember that every V is equal to IR. So, which means that this one is IR plus IR. Okay, this is R of 4 ohm, and this is R of X. Now we can substitute what we know. We know that the current going through both is 1.2. So we are going to say 9 is equal to 1.2 times 4 plus 1.2 times X. And this gives us 9 is equal to, yes, this is what we get. 9 is equal to 4.8 plus 1.2x. So what do we do here? We are going to say 1.2x is equal to 9 minus 4.8, giving you 1.2x equals to 4.2. So, which means that our x is 4.2 divided by 1.2. Giving us 3.5 ohm. Yes, that is the resistance of X. Yeah, then comes this question. It says, calculate the total external resistance of the circuit. Okay. Now, when you analyze this circuit, there are 2 groups of resistors. There is this one, which are resistors in parallel. So we can say R total is equal to RP, representing this one, plus RS. Now you have to know that RP is calculatable, but RS is known is 6. So what do we do under this circumstance? You say calculating RP. So we need to remember that 1 over RP is equal to 1 over R1 plus 1 over R2, giving you 1 over 5 plus 1 over, we have to remember that we got this as 3.5 previously. So 3.5 plus 4, you get 7.5. So this one's going to be 1 over 7.5. So this is what you get, 1 over 3. So we must remember that it is 1 over RP, which is equal to 1 over 3. This means that RP is equal to 3 over 1, giving you 3 ohm. So after getting RP, then we can go ahead and substitute in our equation. Remember, we have RT is equal to RP plus 6. The equation is here. So if you substitute for RP, we are going to get RT is equal to 3 plus 6, giving us 9 ohms. Yeah. Then comes this question. It says, calculate the ammeter reading A. Okay. So this is the ammeter, this is the A we are talking about. And how determine that reading? The best approach here is to follow these currents. You have to know that no current, when current flows like this, no current flows through the voltmeter. So it comes down, it reaches this junction, and part passes here, and part passes here. Okay. Now, the current which passes here is known. It is 1.2 ampere. The current which passes here is calculatable. But we have to know that when this current reaches here, they recombine and passes and go through. So when you look at that flow, the way we saw it, current here, dividing, and then combining, we come to realize that the current going through ampere is I total and is equal to I1 plus I2. Considering that we might call this one to be I1 and we might call this one to be I2. Okay. So if that is the case, then we have to know that I1, we don't know it, but I2, we know it was given. It is 1.2 ampere. So what is pending here is to calculate I1. So we can say calculating I1. Now, this is what you know about I1. We know that the resistor is 5 ohm. Okay. And we know that the PD across that resistor is 9 volts. And we are looking for current. This one gives us a license to use what equation? It gives us a license to use equation V is equal to IR. V is 9, I is wanted, but R is 5, which gives us I being 9 over 5, which is equal to giving us 1.8 ampere, and that is I1. Okay, so after getting I1, what is the next step? Next step is to substitute. Remember, we said I total is equal to I1 plus I2. So I total is equal to I1, which we have just calculated as 1.8, plus I2, which is 1.2. This one will give you I total, which is going to be 3.00 ampere. Yeah, then comes this question. It says, calculate the voltmeter reading V. This is the V they are talking about. This one has so many approaches. You can use VT is equal to ITRT because everything is known. Or alternatively, you can say VT is equal to VP, which is our 9 plus V across 6 ohm. Yeah, because those are the only sets of resistors we'll have. So if that's what we are going to use, we can say VT is equal to 9 plus V across 6 ohm. But now you need to know that every V is IR. So V across 6 ohm is going to be I, which is going to be I total, then R 6 ohm. Okay, when you come to substituting, what is I total? We found it as 3. And the resistance is 6, giving you 18 volts. So with that, what do we say? we are going to say VT is equal to 9 plus 18. Giving us 27 volts. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Self-Ability with me, Richard. We urge you to subscribe, to comment, to like, and share. And we also want to tell you that this channel handles physical sciences, grade 12, 11, and 10, and natural sciences, grade 8 and 9. We also advise you to use our playlist when you're using our channel. Don't use the video because of the scope of this channel. So just go to playlist and click the material of your interest. For grade 8 and 9, just look for natural sciences grade 8 or natural sciences grade 9. For grade 11 and 10, look for physical sciences grade 11 or physical sciences grade 10. For grade 12, every topic is presented independently. So every topic is a tile. Click on it and you'll have all the material you need. With that, I would like to say thank you. See you next time. Bye-bye.